Good day to everyone. I am going to have my coffee break at home today. So while I'm having my coffee, I'm going to discuss about ECMO technology. You might have heard already that ECMO is a technology that was developed over many years and came into a success. ECMO stands for extracorporeal membrane oxygenation. Extracorporeal means outside the body. Membrane oxygenation means the blood runs through a membrane outside the body, and its oxygenation and carbon dioxide release from the circulation happens outside the body, not inside the lung, but a membrane which is artificially prepared to achieve the function. This technology runs back to 16th century initially, and slowly developed. In the late 18th century, this technology was tried as bubble oxygen. Blood was taken outside from the body, and bubble oxygens ran through the bloods, and the circulation was refed by oxygenated blood. But the challenge at that time was whenever you take the blood outside the body, the blood get clotted. Once the blood is clotted, the whole process is sabotaged. So this was the challenge. And in 1916, heparin was invented. So as you all know, heparin can keep the clotting process hindered, and using heparin we can stop blood clotting. So with the introduction of heparin, there are a lot of things happen regarding this attempted technology of extracorporeal oxygenation. And in 1929, a dog was successfully oxygenated outside the body using this technology. But it is not the ECMO which is available in the world today, and slowly developed throughout years. In 1929, Russians successfully oxygenated a dog outside the body. That means the blood was taken outside the body and oxygenated and retransfused to the animal, and the dog was successfully recovered. So the technology developed all over these decades, and in 2009, with the H1N1 pandemic, many people successfully used the technology of ECMO when they failed their ventilation in ordinary ventilators in the ICUs. Now we have come to this COVID pandemic. So during this COVID pandemic, the major challenge that we face with COVID patients is, as you know, the acute respiratory distress syndrome. Initially, we start them oxygenating with nasal cannulas, and then we change to high flow oxygen. When it is also getting failed, the capable candidates are being given CPAP, that is continued positive airway pressure oxygenation, and then intubation, proning, and mechanical ventilation when it fails. Whenever we can't ventilate anymore with the ordinary ventilators in the intensive care units, and if the peak flow is less than 100, ECMO is indicated, extracorporeal membrane oxygenation. There are two types of ECMO. One is venous ECMO. That means we take blood from the body using a pump from a major vein, and the blood runs through a ECMO machine and return to the body by another vein or by another vein. So this is called venous ECMO. The other method is veno-arterial ECMO. We take the blood with the use of a pump from a vein, major vein. Blood runs through the machine and retransfers to the body through an artery. We know venous ECMO is used when a person's respiratory system is failed, but heart pumps properly and there is no defect with the heart system, the heart pumping system. Veno-arterial ECMO is used when both lungs and heart are defected. Most of the COVID-19 patients are benefited by venous ECMO. Venous ECMO is used for the COVID-19 patients in most of the centers all over the world. For an example, in the United Kingdom, there are 5 ECMO centers where you can connect the patients to ECMO machines whenever they need ECMO treatment. In the US, there are so much of stations as well. It is very hard to find a patient who qualifies to connect to ECMO machine because there are so much of contraindications. For an example, if a patient goes to a intensive care unit, usually that patient has multi-organ failure. So multi-organ failure is a contraindication. And if somebody has contraindication for anticoagulation, for an example, if there is a bleed anywhere or any blood leak anywhere, that person cannot be anticoagulated, so he cannot be fixed to the ECMO machine. The old age patients, they are not going to benefit from the ECMO machine because once a patient is connected to the ECMO machine, the patient may stay in the machine for average 3 days to about 2 weeks or more than that as well. So the patient's body or the physiological resources should be optimally sound to fix into this ECMO machine, and it is only the respiratory system which needs recovery meantime while being in the ECMO machine. The other thing is metastatic cancers or terminally ill patients. They are not candidates for ECMO machines. And if a patient has no reversible possibility of the lung condition, that person is also not a qualified person to be connected to the ECMO machine. That is the reason that we can't use the ECMO machines for most of the COVID-19 patients. The limitation is very, very high, and it's very hard to find out the actual qualified candidate for an ECMO machine. Once a patient is connected to the ECMO machine, they have done some statistics and found that if 100 patients are connected, 55% of them may benefit and successfully survive. This is the picture of the first ECMO survivor in 1971. The technology and the machines are not developed up to the level of the standard of today, but you can see that he is being connected to a machine which gives the membranous oxygenation outside the body. Now you can see the picture of a baby, and this is the first ECMO survivor of a pediatric patient, and that was in 1975. Pediatric patients are more benefited by ECMOs because usually their other organs are sound. Here you can see a ECMO machine, and this red box is the artificial lung, which has the membranes, hollow fiber membrane, which helps to gas exchange and oxygenate the blood. And the ECMO machine needs many more units, and it's a complicated unit. And this is the main unit, which is the membrane. Here you can see a patient connected to an ECMO machine, and you can clearly see that there are two lines coming from the body to the machine. One is dark and one is pink. So the dark red one brings the venous blood to the machine, and the light red one takes purified blood from the machine to the body. And ECMO machine needs a few more components. One is the oxygenator, and you can see the oxygen line is coming to the machine, and the exhaust line is going out from the machine. And also the blood should be maintained in the body temperature, and it should be adequately warmed and kept in the same temperature to transfuse back to the body. So temperature regulation is done through a water circuit, and also the gas exchanger, gas pressure is done by a flow meter. On top of that, there is a circular pump which brings blood from the body and in a negative pressure. And there are some meters to monitor the pressure in between. And these are the basic things that you need in an ECMO machine. It's a complicated one, but this is a venous ECMO circuit. And what you do is get the blood from a main vein, like internal jugular vein or femoral vein, and connect it to the machine. Machine purifies the blood, and the blood is retransfused back to another vein, maybe from the same circuit, and same circuit into the same site with a different line, or maybe to another vein in another site. So basic principle is the same. So this is how the patient is kept in the ECMO machine until the lung is being fully recovered. This process takes sometimes days and days and weeks. So we don't know exactly how long that the patient will be there with the support of the ECMO machine when we connect the patient to the ECMO machine. So, summarizing this conversation, I would like to tell you that ECMO machine or ECMO technology is not a cure for COVID-19 patients, but we can mark time and use as a bridge until the lung is successfully cured from COVID-19, and the function of the lung can be handed over to the extracorporeal membranous oxygenator until the lung get successfully cured. Thank you so much.